Welcome to Unit 3. In this unit, we're going to be talking about multiplying and dividing fractions. We're going to start off by talking about ways to show multiplication. Pause the video and write down as many ways as you can to show the multiplication problem 2 times 5. Did you come up with all 4 ways? The first way surely you came up with. I know you know 2 times 5 with a traditional multiplication sign. The second way to show multiplication would be to use a simple dot. That's something we're going to be using a lot in this unit. Make sure you understand that this dot means multiplication. A third way would be a way you might use on a computer using the star symbol. And your fourth way would be to use parentheses and no sign at all. And when you see no sign, what do you try? Multiply. This means multiplication because there's no sign in between. You need to have the parentheses though in this case, because if you didn't put the parentheses, you would just simply have the number 25. But put the parentheses there, and now you have a multiplication problem. We also have many different ways, 4 ways to be exact, to show a division problem. See if you can find 4 different ways to write 12 divided by 4. Pause the video and write them down. Welcome back. Of course, I know you already probably had 12 divided by 4 written this way, very traditional way. Did you come up with this way as well? Lying down, 12 divided by 4. There's also another way that we've discussed a lot since beginning fractions, and that is to show it as a fraction, 12 divided by 4. And the fourth way, which is really related to the fraction way, is 12 divided by 4 written this way. Let's take a look at page 67 in your workbook. Pause the video until you have yours ready. Here we have a page that's going to show you how fraction multiplication relates to regular whole number multiplication, as you're already used to. In our first question, we have this path that is 8 kilometers long, and we have a gentleman, Alex, who's ran around the path 4 times. If I were to ask you how many kilometers he ran, having run around this path 4 times, you would probably use traditional multiplication techniques to take 8 4 times, which would give you a total of 32 kilometers. In other words, 4 times 8 is 32 kilometers. Kento, however, ran around this same path not even 1 full time, but only 1/4 of the way, or 1/4 times. When we figured out our first answer, we simply took an 8-kilometer track and multiplied it by 4, because he ran around this track 1, 2, 3, 4 times. But now we have to figure out how far it is around an 8-kilometer track if you're only going around it 1/4 of the way, or 1/4 of the time. So one way you could do this would be to break up this 8-kilometer track into 4s. If you drew a few lines here and cut this track, we only need to use one of these tracks because he didn't go around the track more than 1 time. He went around it less than 1 time. So if we broke it into 4 equal parts and we label each of these parts, you could see that each part would be 2 kilometers. That would give you a total of 8 kilometers. So breaking it into 4 equal parts means that each equal part is worth 2 kilometers. This is just a visual representation. It's not the way you will be solving most of your multiplication problems. But you can see then that if he only went 1/4 of the way, that could be any of these quarters that we have, that the answer would be 2. And that's an interesting answer because typically when we multiply numbers, we expect our answers, or a product is the name that we give to an answer to a multiplication problem. we would expect that answer to be larger. However, when multiplying whole numbers times fractions, we see that we get a smaller product than what we started with. So to repeat, 1/4 of 8 equals 2. Also notice that I used the word of for this multiplication sign. Of is a word that we're going to be using all the time when multiplying fractions. So when you see the word of in word problems or you hear me say it, you need to know that that means multiplication. You will be using this word quite often as well. I also want to take this opportunity to show you exactly how we multiply fractions. We normally would not use a diagram, although those are excellent ways to find the answers. But typically, we'll be multiplying fractions by multiplying straight across. So here we have 1/4 of 8. We never multiply whole numbers, ever. If we have any mixed numbers, we're going to change them to improper. And when we have a whole number like 8, we can simply change that to a fraction by making the denominator 1. We have now created an improper fraction that equals 8. When we multiply fractions, we multiply straight across. There's a couple of tricks that I could show you that I'll leave for the next video. But here we'll just multiply straight across. And we get 8/4, which is improper, which means the same thing as we learned earlier as 8 divided by 4. And 8 divided by 4 equals 2. You might find it interesting again that we're multiplying numbers, yet we're getting an answer that's less than what we started with. But if you think about it, that's actually quite rational. Because let's say you had 4 apples. 1, 2, 3, 4. If you took 1/2 of those apples, how many apples would you have? Half of them would be only 2. So you can see it makes rational sense, and you can always go back to this example to remind yourself why it makes sense. But taking a fraction of a whole number will always give you a product that is less than the whole number. Pause this video now and complete questions 3 and 4 the same way. On questions 5, 6, and 7, you'll be doing a fraction chain, like the one that they showed you right here. Here they're taking 1/4 of 8. Remember what of means. Then they're showing that as 1/4 times 8, because of means multiply. From there, they're going to go to 8 divided by 4. Now let me show you how they're going from multiplication to division. They're taking their 1/4 of 8, and they're turning that 8 into an improper fraction by putting a 1 under it. That's the fastest way to do that with any whole number. Works for every whole number. They're multiplying straight across, and now they have an answer of 8/4, but remember that's also a division problem, so that's why they're showing it right here as a division problem. 8 divided by 4. So you'll need to do the math and then turn it into a division problem. They're actually then showing it as a fraction, which is kind of the step that I did before the division problem. And then they're going to actually divide it, which is what you're supposed to do if you're looking at a fraction as a division problem. When you divide, you get 2, and that's how they're getting their 2. So number 5 I'll do for you. You can do it with me. 1/3 of 9 is the same as 1/3 times 9, which is the same as 9 divided by 3 after you show your work over here of 1/3 times 9, change 9 into an improper fraction and multiply straight across. There you can see the 9/3, which is the next step is to show 9/3. And now the last step is to divide. 9 divided by 3 is 3. We always want to change our improper fractions to proper. So what we've just shown is that 1/3 of 9, or 1/3 times 9, equals 3. Pause the video now and complete 6 and 7 the same way. Now turn to page 68. On this page, we need to start talking about ways to discuss comparisons. Take a moment and pause the video and read the scenario and try to make sense of the bar graphs that you're seeing. Now we're going to go through this together and see if we've made proper sense of it. We have two bar graphs here, two fraction bars. The first one is representing the amount of quarts that Ryan has of soup, and the second one is representing the amount of quarts that Sarah has of soup. We can tell that Ryan has 6 quarts and Sarah has 2 quarts. We can also tell that they're using R to represent Ryan and S to represent Sarah. Those are the most logical variables to use. Variables are just letters that we use to represent unknown numbers. There are some different ways in which we could say how many quarts Ryan has. One of those ways is listed right over here. We could say that Ryan made 3 times as many quarts as Sarah. We can tell that because Ryan has 6, and we can see visually that that is 1/3. If we break Ryan's 6 into thirds, that 1/3 will equal the same amount as Sarah's. So we could say that Ryan is 3 times as many quarts as Sarah, or we could also say the opposite, and that Sarah has 1/3 as many quarts as Ryan. And as we're saying these things, we need to be able to write expressions and write mathematical equations. When we say Ryan made 3 times as many quarts as Sarah, then we would use R to represent Ryan, which equals 3 times as much as Sarah. If we didn't know what these amounts were, we would just simply use the letters to represent those amounts. Sarah made 1/3 as many quarts as Ryan, so we could write that one of a couple of ways. We could write it as a fraction. Sarah, the amount she has, equals 1/3 of, there's that word of, which means multiply, Ryan's. Pretending we don't know that Ryan's is 6, we'll use R for Ryan. Or we could write that in a different way. Sarah equals whatever Ryan has divided by 3. And when we plug the actual numbers in for these variables, we would say here that Ryan equals 6, and 6 equals 3 times whatever Sarah has, which is 2. We can see that this equation is true. And coming down here and plugging in the numbers that we know, Sarah has 2, and that equals 1/3 of whatever Ryan has, and Ryan has 6. So this equation is true as well. Or we could rewrite that as Sarah, 2, equals whatever Ryan has, which is 6, divided by 3, and we can see that 6 divided by 3 is 2. That expression is true as well. On number 9, you're going to draw comparison fraction bars, just like the ones we used up here. And then on 10, 11, 12, and 13, you will fill in the blanks with the proper words or numbers to make those sentences true. Now that you've completed the last page, turn to page 70. We are going to skip page 69 and go right to page 70. Number 20 says, how many times as many fish did Bill catch as Amy? If you look at the fish caught over here in this graph, and whenever I see a graph, the first thing I want to do is try to figure out what the graph is telling me. And in order to do that, you really need to read everything on the graph. The graph is telling us the title is fish caught at the lake. So they're representing how many fish are caught at the lake. The bottom part of the graph tells you the number of fish. That's what these numbers are representing. And then our left-hand side, is telling you the names of the people involved in catching these fish. So when we look at number 20, it says how many times as many fish did Bill catch as Amy? When we look at how many fish Bill caught, he caught 15 fish. And Amy here only caught 5. Bill caught more than Amy. How many times more did he catch than Amy? Amy caught 5. If Bill were to catch, say, 2 times as many, how many would that be? 10? That's not what we're looking for. We're looking for 15. If Bill caught, say, 3 times as many fish as Amy, how many would that be? 3 times 5 is 15. So Bill caught 3 times as many. You can also see that in a visual way here. We can see that each of these sections are equal. Then we basically have two fraction bars here, and if Bill represents the entire amount that he caught, Amy's represents exactly 1/3 of Bill's. So now you're going to reverse it. The question will be reversed. Now, how many times as many fish did Amy catch as Bill? Pause the video if you need to and write your answer in. Complete problem 22 as well. I will do number 23 with you. We're going to compare Gina's points to Brent's points. So we want to lead with Gina on this. We need to take a look at our graph over here and see what it's telling us. Our title says points at the basketball game. We have 3 players here. Gina, Brent, and Jacob all were playing in this basketball game. All scored points. Gina scored the most, then Brent, then Jacob. Again, we need to start and lead our sentence with Gina because it says compare Gina's points to Brent's points. Well, Gina has scored 32 points and Brent has scored 8 points. So relying on our ability to do math facts, I can tell you that Gina scored 4 times as many points as Brent. You can guess and check that if you need to, but Brent only scored 8, so 8 times 4 is 32. Therefore, Gina scored 4 times as many as Brent. Pause the video and complete numbers 24 and 25 on your own. On to number 26. Here we're using a different graph. We again need to check the graph and see what it's telling us. The length of snakes at a zoo. We have snakes with names, Speedy, Lola, Pretzel. We have numbers. However, our numbers aren't traditional numbers. Our number here is just a variable, n. Here we have an actual mathematical problem, 1/5 of n, and Pretzel here is 5 times n. Well, this is probably looking more complicated than the others. In reality, it's really not much more complicated. We're going to stick with our strategy. Number 26 says, which are the shortest and longest snakes, and how do you know? Well, let's use the strategies that we have learned already. We know Speedy is n inches long. We don't know what that number is. It could be any number. But we know Lola is whatever Speedy is times 1/5. And we learned earlier that when you multiply a whole number times a fraction, you'll get an answer that's less than the whole number. So for example, if Speedy was 10 inches long, Lola would only be 1/5 of that. Not even the same amount of inches, but only 1/5 of it. You'd have to cut Speedy's length into 5 equal parts and take one of those parts to find out how much Lola is. So Lola's not going to be as long as Speedy. Pretzel here, on the other hand, is going to take Speedy's actual length and multiply it times 5 because Pretzel is 5 times as long as Speedy. Now I would like you to pause the video and put these snakes in order from shortest to longest on number 26. I'm going to do number 27 with you to show you how to do it. If Speedy was 25 inches long, then we could just take out this n and plug in the actual number of 25 inches. The question asks, how long is Lola? Well, Lola is 1/5 of whatever Speedy was, so that's 1/5 of 25 inches. Remember that we do not multiply using whole numbers. We change them to improper. This is why we learn to change mixed numbers and whole numbers into improper. In order to do that, it's very simple. Just put a 1 under the 25. Now we can multiply straight across and get 25 over 5. 25 over 5 is improper and should be fixed. It's really a division problem. 25 divided by 5, which equals 5 inches. It's a little bit of algebra. We're just plugging in numbers for variables. Now you can pause the video and complete number 28 to finish your morning math.